I am Eva Sharma, and I am looking over the Habitat Marte's Lunar Habitat Mission 175's engineering facility. Today, throughout this presentation, I will be going through some of the key research and some of the key features of the engineering facility that I have went through and I would like to share with the audience. So first up, just a basic introduction. This is the lunar base that our team has planned in the mission 175, among which you can see the engineering facility written over the facility. It will be in direct connection with the powerhouse. So we will be working in close coordination with the powerhouse for the energy part as well. So these are the basic functions of what we will be doing as a team in the engineering facility. So first up, we will be coordinating with the powerhouse generation for energy generation. So we will be having work focusing on energy generation. We will be also be majorly doing 3D printing works because I believe that is one of the main aspect that we will be highly contributing in developing in building the lunar base and developing it further throughout the missions and throughout the project. Third is maintenance of operational gadgets in perfect working order. As engineering facility members, the crew will also be looking after all the operational gadgets, all the systems that, and if they're working in perfect order or not. The fourth thing is that we will be also be ensuring that the operation, we will be also be operating and facilitating the communications protocol. This will be back to Earth as well as along with the other facilities as well. And then installation and maintenance of different systems in the entire base. I'm sorry, I think the graphics just is over the letters, but I'll just read it out. So we will be also be looking after installation and maintenance of different systems, not just in our facility, but in the entire base. We will be doing R&D works on them, and then we will be also cooperating with other facilities to look after what kind of systems are required and how we can further maintain the system as well. Then we will be working in close with the launch center, with the power center greenhouse, as I mentioned, and we will be also be responsible for planning and executing development and construction activities. Then we will be executing engineering R&D as well as R&D of other facility centers, like I mentioned. We will be also having a water analysis model. This is where we take samples and analyze water concentrations, and this way we will be also be able to look for further solutions on back to earth on how we can further analyze the water resources that we have, and also for further research purposes on the moon. And lastly, we will be also researching on food production. This will be more of bioengineering, I would call it, and this will also be in collaboration with other facilities as well. So these are the R&D subjects that we will be researching on the engineering facility. It will be the structure, the construction material, the construction method, the construction method, resource circulation, resource utilization, food production, and simulated facilities. So these are some of the key R&D subjects, but there will be more R&D subjects throughout the whole mission, like as we move further. So regarding the material and structure, we will be having an inflatable structure. We are going with the basic inflatable structure. It will be more of unfolding origami structure and an outer layer protected by construction material manufactured from local regolith simulant. We will also looking for automating the construction works by automatic and remote control operation of construction materials using GNSS, and we will also be focusing more on autonomous robots for maintenance, construction, and exploration tasks. So the crew does not have much of the hectic schedule for just looking after the maintenance and construction of those activities. So these are a few external features of the facility that I think is really important that we need to look after. The first is I think we will be having some open or transparent things that you can see on the screen that will give natural light can enter inside from. These are sections from where natural light can enter at certain times whenever it's bright outside. The second thing that you can see mentioned in the diagram is airlock plus technical support model. This will be in order to connect with other facilities as well as get outside to work on external missions as well. And as you can see, the protection is our number one priority while developing the facility. By the usage of regolith for 3D printing outside the inflatable structure, it provides protection from solar radiation, meteoroids, and extreme temperature fluctuations as well. So For the engineering facility, the three floors that we have like designated for. The first ground floor, we are working fully on storage, 3D printing facility, open brainstorming space, and vertical garden. The second floor will be the technical engineering center, which will be the main working space from where we will be controlling everything back on Earth, as well as on external data, external research. And the third floor, which is the topmost floor, will be the dormitory of the facility. So this is some designs that I had prepared on AutoCAD Fusion. The first ground floor layout, as you can see, that is labeled on the screen. For the first part, the number one part is where we will be having the entrance. The 2 and 3 sections on two sides of the screen will be the number 2 part labeled will be the EVA suits room. This is where anyone who's going for external missions will be changing their suits, will be going through a cleaning procedures before they enter the facility. The number 3 will be 3D printer room as well as storage. This is for easy access for external missions. The 4 transparent place that you can see on the left-hand side will be the crew up and down ladder area. The labeled 5 area will be an open space where you can just sit. It will be especially important that after missions that you come inside the facility, you can sit, relax for a bit, and then share all that you have learned from outside with the team. This will also be a good open space for brainstorming and to relax yourself after any kind of missions outside. The 6 will be where the protocols are sectioned and also some storage space as well. The 7 is hydroponics research area because we just have a central vertical garden in the middle of the space. So I thought it would be really good if we have a research area right beside where we have the central vertical garden as well. And the number 9 is not shown in this picture, but you can see on the next slide that this is the another view of the section. So here you can see that the opposite part of the sections will also have screens and whiteboards for messages and to note down any points for the crew. This is labeled 2. This will be a fully engineering section where team will be involved in many of the technical tasks. This will be a section where you will have rooms for prototyping, manufacturing. You will have daily data entry of individuals for the health monitoring. You'll have recycling area for which includes a water filtration plant, development lab, and main center in the middle, which is the mission control. This will be the main control area from where the entire crew will monitor everything is going around. You can see a bit of a up view from this section, and this will be more of you enter from number 1, and there will be sections on your left hand side, on your right hand side, and there are different sections, like a section is just dedicated for development, a section is just dedicated for prototyping, one is for manufacturing, and one is just where you go inside and take daily data entry of your weight, of your height, of your nutrients in your body, and just put in any kind of health data for the health facility, as well as to keep a track of your records. The third floor will be the dormitory. Here we will have basic central dining table in the middle. Then we will have a minimal kitchen cabinet and cooking area, which is number 2. We will also have a storage unit, above which is a screen for announcements. Then we have living areas on number 5, 2 sides of the sleeping capsules and dorms. We also have a quarantine area just in case they're sick or they want to distance themselves from the crew just for the safety of everyone. Then we have a gym and a washroom, and we garden. This will not be a circular garden, but this will be a wall garden just right beside the kitchen cabinet where you can fresh pick and eat, as well as also maintain the air quality of the area. We can have a lunar shelter for rovers. As engineering center, we will definitely be having a lot of rovers, a lot of 3D machines, which should have good shelter. For this, I think it's important that we have expandable structures and garage, which will be either inside in the first ground level floor or right outside, which is beside the airlock control. So we can just expand the structures whenever the rovers need the shelter. This will also work as passive heat controls, and it will be a multi-tourist shape as it is quite stable for shelters for rovers like these. So this is one possibility that I looked for. This is the lunar lander Starship that currently NASA and SpaceX has had a agreement on. This is scheduled for, I think, September of 2026, where they are planning on going on Artemis 3 mission, for which they are developing this lunar lander Starship on based on their HLS program, I believe. With this is one theory that has been going on the internet for quite a long time, and it is definitely a possibility that this can help for, especially for establishing our lunar base, along with transporting materials, along with transporting rovers, for our crews to be there and establish some kind of facility to begin the works with. I think this is a really good opportunity that we have, which is quite near as well. So this might open up a lot of opportunities for sure. With this, we have a starship that is of height of 50 meters, where you can see that most of it is covered by the starship components, but the top part of 22 meters, among that, we have 17 meters, which can be used by the crew for their habitation, for establishing their facility outside the starship, or they can use the starship in different levels for their living while they establish anything outside in the lunar base. So this is a really great possibility, and this will definitely open up a lot of opportunities in the future for our lunar base, as well as be a good opportunity for crews to go and establish it, because for them to have a shelter while everything is going around, it's really important. And this I believe is the perfect opportunity for us to get started. This next slide talks about energy. We work with the powerhouse. As engineering facility, we also do a lot of research, which I think will be really important for generating energy. And so what's recommended is we have an expandable solar power generation tower, and about 80% of the time solar energy might be acquired, is what researchers show. And they actually show that more than 10-meter height and at a degree of 85 to 90 degrees at lunar's south polar region is recommended. So we definitely recommend a tower type solar power generator, which is situated at polar regions. And this limits the operation and activity only to sunshine period, so that we reduce the total system mass, since storage battery mass is quite dominant. And for this, as prototype, we can definitely use CFRF, the stable boom support and boom rolling system in solar cells to create a prototype and then further develop this. But we believe it has to be about a height of 12 meters. So this we can collaborate with the powerhouse and work further on generating the energy. So, talking about the applied technologies, I think the main technology required for the overall lunar base construction will be the 3D printer. And as engineering facility, the 3D printers will be one of our main focus area for just not just development of external structures, but also for anything that goes inside the facility. So this is one example of the 3D printer. We have a regular scooper, tank, a six-axis robotic arm, and 3D printing head. Any kind of 3D printers for developing lunar bases, or any kind of facilities at lunar surface. A typical 3D printer could look like this. So this is one example that I found. And another technologies necessary for facility operation is that first up, we have the computing and controls systems, which is really important in various engineering operational functions. We also have environmental monitoring sensors. Sensors are definitely important so we can monitor our lunar environmental conditions, which includes radiation levels, temperature variations, and atmospheric compositions, which is also important for further research and stay at the lunar base. The third is robotic construction systems. We will be having lots of robots and automated machinery for constructing and maintaining the structures. This will just be a great help for the crew, as well as we can use the same kind of systems back in Earth for different purposes as well. For these 3D printers, like I mentioned, we will definitely be having lots of solar panels, a lot of high efficiency solar panels, so that we can convert the solar energy into electricity and any kind of other forms of energy that we need. The next one is power distribution units. These will be systems to distribute and regulate electrical power throughout the lunar base. So that will be quite important as well. We will also be having excavators and drills. These will be for excavation, drilling, mining activities, because we will definitely having lots of caves at the lunar base, and this will support construction and resource extraction. We will need life support systems to regulate air compositions, pressures, and temperature. Water recycling unit will be one of our main research focus area, because water is a really scarce item component that we also need in the lunar base. So this will be a system for recycling and purifying water to ensure that we have sustainable supply for drinking, hygiene, and other needs. Then we have waste management systems, so we can practice sustainability. We can have technologies for handling and processing solid liquid waste, and which includes waste to energy converters, and definitely hydroponic systems. This will be technologies for growing plants and producing food in a controlled environment, and microscope for spectrometers. This will be for research purposes, high precision instruments where we will analyze samples and we'll be constructing experiments. So these are from few of the possible resources that we can generate inside or can be transported from Earth. Talking about management, this is the organizational structure and management. So first up, we have the facility chief, who I think should be an experienced astronaut with past executed space missions, so that their past experiences as well as qualifications will come handy. We will also be having two system engineers, one of them of which will be a software lead and one of them will be a maintenance lead. Two of members in research team. One of them will be looking after inspection and development, and one of them will be looking after R&D. One of our telecommunications and data scientists, one assistant who will be looking after all the sub facilities and assisting everyone, and one health and nutrition lead, so that we can ensure that all of our crews are in perfect health. Regarding the positions and astronaut profile and responsibilities, all members of engineering facility, I think my personal opinion is that they must be academically and technically strong and must have the ability to think creatively and act precisely, because as crew members of engineering facilities, there are times when you have to act suddenly, where you have to act really creatively. So this might come really handy at a moment like this. First up, talking about the profile and responsibilities, we have the facility chief. They must be a qualified engineer with previous experience of working on successful space missions, as well as must have leadership quality. The responsibilities will be that they will be leading the facility works, and they will be also overlooking the decisions. They will be also responsible for the daily inspections of the tasks going on in the facility. So they will be monitoring everything. They will be responsible for reporting everything to the main station, and they will be also coordinating with mission control with the engineering focus that is back on Earth. They are also responsible for updates to the main center if any emergency requires. Okay, next up we have the system engineer and software lead. They must be a mechanical engineer or a software engineer. I think software engineer is preferred. Their responsibility will be to maintain the focus on the space system as a whole, rather than a collection of functional elements. So they will also be looking after the software mechanisms of all that is going in the other parts of the facility. They will be regulating the entire lunar base to ensure the mission remains on track. They will also be overseeing the integration of software with various subsystems such as communication, navigation, environmental controls, and robotics, and they will be conducting regular code reviews and performance assessments to maintain software integrity, and they will plan and execute software upgrades and enhancements to improve system capabilities. So they will be working with their focus on the software side of the mission. They will also be just in overall just have a regulation over the entire lunar basis software protocols. The next one we have is a maintenance lead as the system engineer. They must be a qualified mechanical engineer and previous experience of working on successful space missions. They will be having a lot of scenarios where they have to perform hands-on activities that will be spontaneous most of the times. So they will be leading the facility works, and they will be also overviewing the decisions. They will be responsible for the daily inspection of all the tasks that is going on. They must be able to quickly identify and diagnose issues or malfunctions in equipment and systems, and they must be able to provide feedback on hardware performance and reliability to inform software updates and improvements. They must also be prepared to respond quickly at emergency situations, which includes equipment and system failures, which might be a big disaster. They will be working in collaboration in cooperation with software lead to implement emergency software overrides or adjustments. Next, we have the inspection and development lead. Their profile is that they must have previous experience of working on space missions, so they know what they are inspecting and they know what developments they wish to see in the future. So they will be looking over the facility works and they will also be brainstorming for the development activities. They will be conducting regular inspections to ensure compliance with safety standards, operational requirements, and engineering specifications. They will be coordinating with the R&D lead on development activities to enhance the lunar base, and they will be inspecting each component of the base, and they will be reporting to the facilities if repair and development is required, and the people who are in coordination of the specific facility that needs the repairments will be looking after it. Next, we have the R&D lead. They must be a qualified engineer with previous experience of working on successful space missions. Again, they will be leading the 3D printing section of the engineering facility, and they will be coordinating with other facilities to figure out the R&D demand in the overall lunar base. They will also be ensuring that projects are completed on time, especially within budget, and meet the specified objectives and quality standards. And they will be also looking for managing the R&D budget and ensuring optimal allocations is required. They will also be responsible for keeping a track of all that the 3D printing is being done of. Next, we have the telecommunications and data scientists. They must be a qualified data scientist engineer, and they will be looking over the data of the ongoing researchers at the facility. They will be responsible to communicate information with the ground station, mission control on Earth, and they will be responsible to maintain quality communication networks that support reliable data transmission within the lunar base and between the lunar base and Earth. And they will be also responsible for R&D of new telecommunication technologies and protocols to enhance the efficiency, reliability, and range of communication systems in the lunar environment. We have the health and nutritional professional who should be a skilled health professional. They will be responsible as a part of the health facility, but they will be in constant touch with the health facility. They will be reporting everything to the health facility, but they will be working in the engineering facility itself. They will be conducting regular inspections of food storage, preparation, and handling processes to prevent contamination and ensure hygiene. And they will be also organizing and promoting recreational and wellness program, including physical fitness routine, relaxation techniques, and social activities daily or once a week. They will also be conducting regular health assessments and medical checkups for all personnel, and they will also ensure all crew members log in their health data each day. So they will be responsible for the entire health part of the crew members. Next, we have the technical assistant or assistant in general. They should be an engineer and they should be technically sound. They should have knowledge about all the sub-facilities of the facility. They will be assisting all the crew according to level of urgency in their task, and they will also act as a medium between the engineering facility and other facilities if any coordination is required. They will keep track of all deadlines and remind the crew accordingly, and they will also be managing the laboratory tools. So these are a few resources required for astronauts, especially on the beginning days of the missions. First up, we have oxygen. That is approximately 0.84 kg of oxygen for breathing. This is per day estimation. We also have drinking water, about 2 to 3 liters, which I think is really important for them to stay hydrated. We also might need additional water for hygiene, food preparation, and other needs, which I've set to approximately 1 to 2 liters per day. Talking about food, the calorie intake of around 2,500 to 3,000 calories, depending on the astronaut's activity level, which translates to about 1.5 to 2 kg of food per day, including a balanced mix of proteins, carbohydrates, vitamins, and minerals. And typically, an astronaut produces around 1.2 liters of urine and 0.1 to 0.2 kg of solid waste per day, which can be further looked on to how we dispose them correctly, sustainably, or go further on the filtration process, which can be reused and recycled. Talking about the astronaut training program, so it might be really good if the astronauts have a technical degree. This will definitely make the training procedure smooth, and even preferred if they have a STEM degree, so that they are academically strong, since these will be the first missions on Moon, and it's really important that those who are academically and technically sound are there. First up in the phase, we have the physical endurance training, which will go for about a year. Then on the phase 2 of the training, it will be a systems operation training of about 9 months, where the astronauts are trained on how to execute the systems and how to operate the system. Then we have team bonding protocols and psychological training for about 9 months, where they are counseled on everything that they should know, and just being quite close with the team in general. Then we have mission planning and execution procedure, where the astronauts will be trained on how they plan a mission and how they execute it. What are the steps from the beginning to the end, an end-to-end procedure. Then they will have a simulation based on different scenarios, looking after the worst case scenarios as well, so that they are well prepared. So these are a few pictures that show a few of the physical endurance training happening for astronauts. It could include treks with backpacks, really heavy backpacks, so that astronauts also get quite feasible on the spacesuits, which will be quite heavy, running about 5 kilometers 2 times a day as beginning, undertaking scuba diving training and being certified, weightlifting and gym regularly, get nutritional advice and have a balanced diet, and flight simulations. So these will be some aspects of the physical endurance training, so that they are physically fit and trained for the missions. Next, we have system operation training, where they will operate and get used to using technical instruments. They will also gain experience to fix or troubleshoot issue if any arises. They will understand the system operation, and they will familiarize using the system with and without spacesuit under different circumstances. It might be underwater or at zero gravity simulations, just so they're prepared within their body to perform the task as well. Then we have simulations based on different scenarios, like Habitat Marte does. They prepare the astronaut to work under different circumstances. This could include training in caves, lunar analog habitats, etc., and also look out for worst case scenarios and prepare them to work during it. So these are a few of the other astronaut training resources. This could include collaborating with space agencies and training astronauts as part of the astronaut training program. These are a few of the links from NASA, ESA, and Canadian Space Agency. So what they basically do is they perform the basic training and they certify them of the basic training. Then that goes to advanced training, and then the procedure moves on. So this could be one of the options to train the astronauts in a certified way as well. And these are some of the online resources from YouTube that could help astronauts learn what it is like to be an astronaut, how to stay alive in space, and just how to survive long periods of isolation. This also talks a little bit about structural engineering on the moon, and how we can have a settlement on the moon, and how important it is for astronauts to take a good mental health advice and work on it as part of their daily schedule as well. Talking about astronaut candidacy training safety, it must be ensured that missions are carried out in the most rigorous possible manners. So this also means that a risk will come, and the risk must be calculated prior, at least during the training time. This will also, the training activities will try to execute tasks in environment of utmost similarity to Moon. So to monitor the safety and performance during the training, candidates will be constantly in touch with mission control through Capcom, even when in lunar base, and the technical team will ensure that the mission is executed safely. The planning and coordinating of all activities is done under superior surveillance for first-time candidates, and candidates should also practice communication with the station at delayed time to simulate the time it takes for each message to travel from Moon to Earth and vice versa. This communication latency is easily customizable, depending on the movement of the plants or the specific requirements of the mission. So basically, I found this online that Earth to Mars it lasts between 4 and 24 minutes, depending on positioning. So astronauts could train on the standard time delay, which could be set at 8 minutes each way. So this way, they are also quite familiar with how the communication protocols work. Talking about protocols, we have 3D printing protocols as part of the engineering facility, which includes design and measurement of components must be finalized printing, and use post-print inspections to ensure all parts meet required specifications and standards. We have store printing material in designated control environments to prevent contamination or degradation. Ensure that the 3D printing area is equipped with proper ventilation to remove fumes and particulates. This also includes installing air filtration systems to maintain air quality and protect persons from harmful emissions that the 3D printing could provide. Maintain optimal temperature and humidity levels in the printing area to ensure material integrity and print quality. Document maintenance activities and incident reports for future reference and important, and recycle all leftover filaments. Talking about entertainment and occupancy protocols, we could develop a schedule of structured leisure activities to provide a balance between work and relaxation. Activities might include movie night, game tournaments, or talent shows just to keep the astronauts engaged. We could ensure that there are reliable communication channels for crew members to interact with family and friends on Earth, supporting mental well-being and maintaining personal connections, as this is a time where we connect with everyone on phones during all times of our day. So they might feel quite lonely, especially when you cannot connect with your families back here at home. Utilize VR systems to create immersive experience that simulate activities and environments not possible on the lunar surface. This could be activities like exploring different landscapes, playing interactive games, etc. We could also keep track of and celebrate crew's personal important dates as well as mission milestones. Talking about safety protocols, we need to regularly check and maintain air filtration systems, since that's, I believe, quite important for our survival. Install sensors to monitor oxygen levels, CO2, and other hazardous gases. Regularly inspect the facility for structural integrity. Maintain a maintenance schedule for all the structural components. This is as part of the engineering safety protocol. Ensure all machinery and equipment are regularly maintained and inspected. Ensure all PPE is regularly inspected and maintained as well. Conduct regular safety training sessions for our personnel, perform emergency drills for various scenarios, which includes fires, decompression, radiation leaks, implement rapid decompression protocols and training, and ensure airlocks are regularly inspected and maintained, and definitely regularly clean and maintain surface to reduce dust accumulation. Talking about food microproduction protocols, we could install HEPA filters, UV sterilization systems to maintain clean air. These are items that we need to bring with the astronauts while they set up the base, so that they have clean air and sterilized systems while they are there since the really beginning itself. Monitor and control CO2, oxygen, humidity, temperature levels to optimize plant growth. So the section where we have the hydroponics research, it's really important that the data are optimized to ensure the plant growth. Implement precise nutrient delivery systems. Monitor nutrient levels continuously and adjust as needed to meet plant requirements. Store harvested produce in controlled environments to maintain freshness and prevent spoilage. Use preservation methods such as vacuum sealing and freeze drying for long-term storage, and collaborate with other teams to test new crop varieties, production techniques, and resource management strategies. Talking about technologies and outputs that could be applied back in Earth, first one would be hydrogen-based supply chain, which would be to use hydrogen as fuel energy, promotion of renewable energy, reuse, recycle, circular ecosystem, economy system, which will be really much used while in the lunar base, technology for energy production, building infrastructure, the 3D printing evolution that the building the lunar base will bring forward, growth of vegetation, researches on R&D will definitely be useful, and research on sustainable measures of living. Next, we have the impacts to sustainable development goals. Through our project at the lunar base, I believe that we will be complying few of the goals, one of which is good health. We will be ensuring that the astronauts, the crew, are in good health throughout. Gender equality, there will be definitely no bias during training as well as during lunar base missions. Goal number 6, which is clean water and sanitation, since there will be lots of focus on the sanitation part as well as clean water, where we will be researching on water facilities, recycling water. This will be also looked on. Goal number 3 will be affordable and clean energy, where we will be researching on different kinds of energy mediums that we can use sustainably, which is also going to be affordable. This we can use back on Earth as well. Goal number nine is industry, innovation, and infrastructures. I think the 3D printing part really comes under this goal, where the innovations and infrastructures development from 3D printing will can be seen in this. Goal number 11 is sustainable cities and communities, which also interrelates with goal number 9. Goal number 12 is responsible consumptions, as crew in the lunar base will definitely be really sourcing on each kind of resource that they have. This will definitely bring on opportunities for researchers to look on responsible consumptions and how we can responsibly and sustainably consume. Goal number 13 will be climate action, with bringing forward solutions for energy and solutions for different kinds of sustainability measures. We will be definitely promoting on climate action. And goal number 17, which is partnerships for the goals. The lunar base will not just be a project of a country, but it will be a global project. It will bring forward partnerships of different nations and different continents, different space agencies. So this will definitely contribute for partnerships as well. So thank you. This is my presentation, but I would also like to have a small session, if the time allows, regarding the additional segment on stinging nettle, which I wanted to discuss with the team as well as part of the health protocol that we were talking about a few days ago. If Professor Julio agrees, I think I can move ahead with this.